Okay, so today's lesson is on special angles. So we're going to first of all start off with sine 45 degrees, cos 45 degrees, and tan of 45 degrees. Now, if you type those into your calculator, you'll be able to get an answer straight away, but I'm going to show you how we can get it by using a simple triangle. So I'm going to start off, I suppose, with my unit circle and some information here. I'm going to start from here to here is 1, and from here to here is 1 as well. And what I'm going to do is I'm actually going to draw myself a triangle that goes from here to here. Let me fix that up so it looks a bit better. Okay. All right, so in red, what I'm going to do is I'm going to mark that I know that this line here is 1, and I know this line here is 1, okay, because it's this length here. And I also know that right here is a 90-degree angle, so this is 90 degrees. And these two angles here are 45 degrees. Okay, and the reason for that is that they are the same length. Okay, so looking at just this piece of information here, I might just make it a little bit tidier. Okay, I'm going to be able to figure out some piece of information. Now I know the length of this is 1 and the length of this is 1. I'm easily able to find out what the length of this one here is. I'll call it x. And I do that by Pythagoras' theorem, where I know that this is my right angle, so therefore this is my h, and it's h squared equals o squared plus a squared, or a squared equals b squared plus c squared. And I've got h squared equals 1 squared plus 1 squared, h squared equals 2, h is equal to root 2. So I now know that this part here is root 2. And now that I know the lengths of all three of these sides of this triangle, I can easily work out what is the sine of 45 degrees. So I know that this is 45 degrees, so I'm going to place a big green here. So if that's the case, let's label it correctly. So right opposite it is going to be my opposite. My hypotenuse is still going to be here, and my adjacent. And so my sine of 45 degrees, sine equals O over H, is going to be equal to 1 over root 2. So that's how you can do it by using a diagram. I can do cos now. Cos of 45 degrees, and cos is equal to adjacent over hypotenuse, which in this case should be 1 over root 2 again. And if I'm asked for tan of 45 degrees, I know that that's O over A, and that will be 1 over 1, and so as a result is 1. So these ones we know, they're written in our log tables, but where do they actually come from? So you can have an idea there. That's what we call a special angle in trigonometry. And I'm going to bring you on now to talk about more special angles. Okay, so now we're going to focus on the 30, 60, 90 triangle. And we're mainly going to focus on the 30 and 60, and we know that when we add them together we will get 90. And just so you know, pairs of angles that add together to give you 90 degrees in trigonometry are usually very special. Okay, so we're going to start off with an equilateral triangle. Okay, and what I'm going to do is, I'll just make this a little bit neater. Okay, and I might call this of length 2, this one of length 2, and this one of length 2. So we know with an equilateral triangle, all the sides are equal. We also know that if all the sides are equal, all the angles are equal. We know all the angles in a triangle add up to 180, so this is going to be 60 degrees, 60 degrees, and 60 degrees. What I'm going to do is I'm actually going to drop a perpendicular down here and create a right angle triangle. If I create a right angle triangle like that, I'm going to just zoom in on one of those. Okay, so the information I know now, if I drop a perpendicular, this is equal to 90. I already know that this angle hasn't changed at all, so this is 60 degrees. But this angle has been halved because of the perpendicular, and it's now 30 degrees. The information I know that this side here, I haven't changed at all, so it still remains 2 units. But this side here, the bottom bit here, was halved, so this remains 1 unit. And then the last one here, I don't know, but I'm going to find out the length of that. And to do that, I'm going to use Pythagoras' theorem. So Pythagoras' theorem, h squared equals o squared plus a squared. My h is always opposite my right angle, so it's going to be 2 squared equals 1 squared plus x squared. 4 equals 1 plus x squared. 3 equals x squared. X is equal to root 3. And it's not plus or minus here because obviously we're dealing with distances. So let's fill that in where appropriate. So I have now root 3 here. And now I'm going to be asked, can I tell what is the sine of 30 degrees, the cos of 30 degrees, and the tan of 30 degrees without using my calculator or my log tables? So if that's the case, the sine of 30 degrees, so it's O over H in this case. This is my angle here, so I'll make it yellow. Therefore, this is my opposite. Then this is my hypotenuse, and this is my adjacent. And so O over H is going to be 1 all over 2. So sine of 30 degrees is a half. Cos of 30 degrees, A over H, so it's going to be root 3 over 2. And tan of 30 degrees, 1 all over root 3. Okay, so without using my log tables, I can easily figure out all of those. And the same then for the 60-degree angles. So I just want you to take down all of these notes tonight, and also using this triangle here that I've just done, can you please tell me what the cos of 60 degrees is, the sine of 60 degrees, and the tan of 60 degrees. And once you've done that, I'd like you to do page 235, questions 1, 2, and 3. And I'll see everybody tomorrow.